Hello everybody, welcome to another episode of Ferroque Systems Working From Anywhere. Today we are on location in the South China Sea. We just left the Hong Kong marina and we're in our yacht here. Some of you have probably asked us like, where we're gonna take this concept to next, right? You saw us did the fastest moving workspace in a Lamborghini. You saw us taking it back to the 1950s Chevy by the Malecon in Havana. And you've seen us did a few other things in the last couple of years, and you keep asking us where we're going to take it next. Today we're actually going to take all the technologies that we have and we're going to actually install them in this yacht and be able to literally work live. We're going to conduct meetings, we're going to actually do some really cool demonstrations, all live with equipment that we install in this yacht and in the middle of the ocean. So sit back, relax, let's go. All right, so here we are in our virtual workspace inside of the yacht, and the first demo that we have is Citrix DAS. We put together a bunch of equipment. Mike is going to actually explain to you what we did to actually make this happen. But we are actually now live launching a Microsoft Teams meeting session inside of a Citrix virtual desktop. Here joining us live is James Shu, the product manager for HDX at Citrix. And we're gonna talk about what made this possible so that we're able to actually work from a yacht in Hong Kong in the ocean and connecting to a virtual desktop in Canada. Tell us.
All right. Hey folks, so what we've got here is an iGel Thin client that is running a Citrix VDI courtesy of Citrix DAS with the Teams optimized HDX session running on a portable data center that we've got here on the yacht, connected through Cato to our corporate WAN over SD-WAN using mobile cellular networks from a yacht in Hong Kong. This is mildly ridiculous, but really shows the extremes that a lot of the combinations of the right technologies working together create very usable work experiences for employees and contractors alike in varied set of business conditions. So, James, how are things running on your end? Because this looks pretty darn smooth to us. Can you tell us a little bit about the technology that's actually making that happen in the back end?
This entire process is actually going through our Microsoft Teams optimization on HDX. So I'm going to actually show you a little bit of the diagram on actually what's happening behind the scene. The first step, I just want to go through the first round of the trip, 12 round, right? So your endpoint, which is located in Hong Kong right now, right? It's connecting to a virtual desktop that is running in, I guess, Toronto, I assume. Right. And then my machine right now is actually a virtual desktop running in Miami data center. And then I'm connecting as a user to that virtual desktop on my end, right? Both of us have the Microsoft Teams running inside this virtual desktop, but it only serves as just a initial session initiate protocol with the Microsoft Teams services, relay services. And then when we're making the call, what really happened is that the Storm services will actually connect the two client and the user together directly. So the actual media content that we're doing right now, sharing the screen, you're interacting with me with your mouse. You can move your mouse around. You can actually see that it is moving on my screen as well. And so we're actually carrying this conversation through via this optimization. So all our video content that we're sharing, my video webcam and also my audio stream bidirectional is all going directly from my endpoint to your endpoint through Microsoft Cloud Services. Okay. So, that's the beauty of it, and that's why we're able to get such a smooth interaction when even you have such a high latency between the two points.
So what other aspects of the HDX stack are making this experience possible? I mean, we're sitting here on a mobile cellular link. The VDI is exceptionally responsive for the latency that we're incurring going here. What's making that happen? What's really, I mean, a lot of people say that the protocol wars are over and RDP is good enough and what have you. I think I'd be a bit challenged to run under the similar conditions with just RDP, for example. So what else is going on here that's actually making this experience so not just tolerable, but actually very usable under these fairly less than ideal conditions, you would say?
Right. So I think one of the key points I want to mention is that not just the video optimization that we have for this call, the entire application that's running inside the virtual desktop is delivered to our HDX protocol, which we have a lot of transport optimizations. And also we have many years of improvement in terms of a video codec and compression. And we're able to deliver a mixed codec in the video to the endpoint so that we can render the right content with the right codec for the customer with the minimum configuration. And these enhancement gives the user best user experience when they're running application inside a virtual desktop. And while real-time communication calls direct point-to-point connections, then we can actually use these optimization to work.
We have brought in a bunch of different technologies to make this happen. We created a satellite office, a satellite data center, some virtual desktop infrastructure in order to actually make everything we need to do working remotely here in China Sea available. Here we have with Mike, he's going to walk us through of what we actually put in here to make this possible.
All right, thank you, Todd. So what we've got here is nothing that's extraordinarily different from what a lot of other companies and institutions might do in the field where they've got distributed or mobile workloads. I mean, the type of technologies we've got here, we may find on a Humvee in a military vehicle in combat. We may find it on buses or satellite offices elsewhere, or on ambulances and police cars or whatnot. So all we've done is take those types of technologies, current versions of them, and couple them with technologies from various vendors that we work closely with to provide an awesome experience here that we've been demoing to you. So at the heart of our little situation here is an Intel NUC that's acting as our portable data center, if you will. So it's running a number of workloads from some VDI workloads to cloud connectors and a domain controller, and that's all connected up and managed through our central VMware vCenter up in our main data center, and all connected through the SD-WAN. The hypervisor itself is connected to our Cato socket, and our Cato socket is what's providing us that SASE and edge security and SD-WAN capability that we use at Ferroque and that we offer to our customers. So it's securely connecting us to our corporate networks via SD-WAN over mobile links. And the mobile links are provided through a Cradlepoint device that's connected to the Cato device. And that Cradlepoint device is essentially a large Wi-Fi and dual SIM cellular modem that is providing us the ability to have redundant SIM cards, 5G, LTE capabilities in there, depending on your service offering or whatnot. And that's also attached to, probably say, an industrial class antenna that is being used commonly, let's say I think this one is actually designed for buses or other mobile use cases where you've got workloads that need the best possible signal available to attach to the, for the cellular links as they're in motion. So that's exactly what we've got here and about. Therefore, we went with that particular device. All those things coupled together are what's providing us our little portable data center setup that we've got. That's allowing us to have workloads available to us. That's providing network connectivity, both from a connectivity and SD-WAN standpoint, but also a security standpoint. And at the very tail end of the chain is our iGel Thin Client. Our iGel Thin Client over here is actually a repurposed Lenovo T460S laptop that has reached the end of its life, and we're able to actually breathe new life into that simply by throwing the iGel OS 12 on it, which is part of the new Cosmos iteration of their product stack, which is actually really awesome, by the way, because we've done two things now. The OS 12 is a bit of a departure from the traditional thin client because it can pretty much act like a full OS, which is great. It's actually a nice alternative to Chromebooks and the Chrome OS, especially because of how aggressive and collaborative IGEL has been with various technology vendors to ensure that it has the broadest level of integration and capability for so many different EUC collaboration tools and the like that are out there. So it's a great option, and with that software on there, that operating system specifically, we've been able to extend the lifespan of devices we were otherwise going to retire, saving us money and saving customers money, and that's a core strategic objective of IGEL to begin with. So glad that we had that working, and it's been working pretty darn well for us in this demo.
Effectively, we actually fit the thin client, or the IGEL device you want to call it, the cradle point, the Intel NUC, and Cato socket, all within one suitcase. And we actually brought it here, and we actually set it up and made it possible here in the middle of the ocean.
All right, so we've taken just a minute here to talk about things other than Microsoft, because although Microsoft is is a key component of EUC and collaboration, EUC, end-user computing, user productivity, it's not exclusively a Microsoft story. So we've got James over here again, and what we've done with James is just set up a quick Zoom call. So the VDA that we're running is got the Zoom client installed in it for VDI, and it's interfacing with the Zoom components that are running on the IGEL device as well, and doing a similar offloading capability as the Teams optimization that we demoed with you. So James, how's it going for you over there? Still a fairly smooth connection?
Yeah, so in this situation, what I have is a virtual desktop, a Citrix virtual desktop running in a data center in Fort Lauderdale. And then what I have here inside the virtual desktop is that I'm running a copy of Zoom client. And this particular client is a Zoom VDI client, okay? And in the on my local PC, I have the VDI media plugin installed alongside with my CWA client for Windows. Now, if you run if you open up the settings under statistic, there is a tab called VDI. It actually tells me that currently what my client version is. This is actually my VDI plugin on the client side, and it's currently connected to this session. So all my video call right now, including my screen shares, all these are controlled through the VDI client optimization, right? So my video call and my audio call right now to you is actually directly coming from my local PC through the internet to your devices located in I guess Hong Kong at this moment, right? So and that's in a nutshell. We could actually optimize also these calls directly from the endpoint.
So at the end of the day, the goal is the same. Lots of multimedia data that could be getting shoved down the pipe through the Citrix VDI that could just further compound and add stress to the network links that we have. So just as with these other and collaboration tools we've been talking about, like Teams optimization, the Zoom client does the very same thing. And there's a lot of other collaboration tools out there that are working in an optimized way as well. But the name of the game is to not backhaul the data from our endpoint to the VDI and then back out to the cloud platform and so forth. We established direct connectivity to take that rich multimedia, the screen sharing, the audio, the video, and have a more direct connected route from our endpoints or whatnot, so we can leave that precious bandwidth to the rest of the interaction of that VDI to ensure that it stays snappy and generally awesome.
We're gonna pay a little tribute to our friend and mentor Mark Templeton and the WorkSpot team. There is a really interesting feature that WorkSpot has, which allows your desktop that's hosted in their in either the Azure or AWS or Google Cloud be able to actually follow you from one side of the world to the other side. Mike is going to log in here, and technically it should actually launch a desktop from Azure Hong Kong.
Just going to log into the WorkSpot portal. Hopefully I typed my password correctly. So while this is loading up, let's talk real quick about some of the advantages that WorkSpot has. So WorkSpot as a technology platform is one of the only DAS, VDI, Cloud PC platforms that actually is able to span multiple hypervisors and multiple public clouds from a single pane of glass, which is a great, great feature. So one of the things that sets, even though it uses RDP as the display protocol, what sets it apart from other architectures is their focus on keeping the latency between the user and the actual Cloud PC, the desktop, as low as possible. So the most important thing to them is to keep that path as short as possible. So what that means is you keep the desktop close to the user, and in addition to that, they keep the gateway. So when the WorkSpot environments, anywhere you've got desktops, you have gateways that are close to the desktops, and they're not shared, they're not points of presence that are shared amongst multiple people, they're shared amongst only within the customer. So we're connected to this WorkSpot desktop through a gateway that's local to the desktop itself, and it's local to us. That means that the overall user experience is different. And this is why WorkSpot's had great success when being compared to AVD or Windows 365 and other types of solutions, due to their ethos and their architecture, even though they're largely using the same operating system and they're using the same protocol. So here we are, just to further iterate that we are not running this locally. We are getting some rather insane speeds coming through our test here on speed test. Desktop works just the same as any other desktop. Here we are, just do our good old Microsoft and our recorded videos from a demo we just did already. Boom, there, awesome, wonderful. Works the same as any other old desktop or whatnot, except it's certainly a great user experience, especially considered that we're connecting over to this through wireless communications. That's
in the middle of the ocean, again, in the middle of the ocean, right? And it did actually follow us. It followed us from the Canadian data center to the Azure data center here in Hong Kong. All right, so hey, that was a great day. It was a lot of fun, eh?
pretty good.
A lot of people that we met in the last couple of years, they ask us what is our obsession of creating these workspaces in extreme conditions. What makes it so obsessive for us, Mike?
My personal perspective, and that of many of my teammates on our delivery team, is their love of engineering, getting their hands on new technology. So we find that often, even during all these things that we've been doing for this journey so far, is we over-engineer all sorts of stuff. The old adage of less is more. We learn the hard way generally, but we have a lot of fun exploring, figuring out what works and what doesn't work through that process of just over-engineering and making everything over the top.
And I think that, for me is, I always tell people that the concept of pushing things to the extreme, it may seem excessive, but really if you look at the analogy of the comparison with the automobile industry, right? You have, we were just at the F1 last week in Montreal, right? In the Formula One pushes the limit of vehicles and how fast they can move. But there's also a lot of technology that trickles down into what we have every day, right? So I always aspire of try to push our technology boundary to as far as we can, so that we learn all these little things that you said, right? And we're gonna talk about what we learned in a second, right? and I think we learned a lot by pushing the boundaries. Useful information, actually, not just fun to share. So one last thing, you might ask. Well, we're gonna ask ourselves, where are we gonna take this next? So now we have done it in the fastest moving vehicle. We have done it in 1950s vehicle in a closed out world, in the world Cuba, and now we're here in the middle of the ocean. Where are we gonna take this next, Mike?
So I've got two ideas, two votes: Mars or a submersible. Get a poll going.
Yeah, there we go. So. There, guys. Either we're gonna go to the moon or the Mars, or we're gonna go under the ocean submersible. Tell us what you think. You never know. We may actually just made it happen. So thank you from Hong Kong. We're out.